Good evening all. You're welcome to the Schoolboy tutorials on pharmaceutical calculations. Today we'll continue from where we stopped in our last class. But actually, based on our program, we agreed that Monday, being second, we take a look at enlargement of formulas. What again? Dosage calculation of pharmaceutical measurement, right? But we have carryover from Sunday. We treated only what? Only concentration, right? We didn't treat specific gravity. I think we should start from that. Huh? Yes. We've treated isotonic solution. I did dilution with you now. We treated isotonic solution and dilution. So yesterday was concentration. So today we'll continue with what's it called? With density and specific gravity. Okay. So did you choose any questions we'll look at? Please copy it on the board as usual. Okay, let's look at what we have on the board. The first question says, so let me put down the questions. I'm coming. Okay, the first question says, the weights, is this in kilogram? Check where. Is it in kilogram? The weight, comma? Okay. The weight, comma, kilogram of 5 liters of sulfuric acid with a specific gravity of 1.84 is dash. Remember from our definition of specific gravity, we said that specific gravity is simply the what? The formula is simply the what? Weight of substance over weight of equal volume of what? Water. Okay? Weight of substance over weight of equal volume of water. Actually, the general definition is actually weight of substance over weight of equal volume of the standard. Basically, weight of substance over weight of equal volume. The specific gravity of a substance is weight of that substance over weight of equal volume of a standard. The two standards we normally use are water and what? Hydrogen. Hydrogen is used for gases. It's standard for gases. If the substance in question is a gas. Let's assume now, if you are talking about oxygen now, the specific gravity of oxygen is weight of oxygen over weight of equal volume of what? Hydrogen for gas. But water is a standard for solid and what? Liquids. So if you are talking about solid and liquid, the specific gravity, use water as standard. So because this sulfuric acid now, use water for a standard. Simply say that the specific gravity of sulfuric acid is the weight of sulfuric acid over weight of equal volume of what? Water. Now, what is the meaning of that weight of equal volume of water? Now, if you get sulfuric acid now and pour in a tin and get water and pour in the same tin of the same volume, they will not have the same weight. True of us. If you get a cup, let's say a cup, the same size, 2 cups, the same size, and pour sulfuric acid to fill that cup, keep it, get the same cup, the same size, pour water and keep it. If you weigh 2 of them, they will not be the same weight. Sulfuric acid will be heavier than what? Water. Now, they have the same volume, right? What is the weight of sulfuric acid that have the same volume with what? Water. Simple. Is it clear? That what we mean by what? Weight of equal volume of what? Water. Am I communicating? Or simply say in a way that you will understand it. Weight of, okay, see, let me explain better. I think that there's a mix up. Same for space gravity is what? That's simple, right? It's equal to what? Weight of. Let me still use sulfuric acid as an example. Weight of what? Sulfuric what? Acid over what? Weight of what? Equal volume of what? Equal volume of what? Water. Now, there's a mix up in what I explained before. Just listen. Let's explain using this thing now. Watch out. Specific gravity of sulfuric acid is weight of sulfuric acid with weight of equal volume of what? Water. I want to ask you a very important question. This weight here now, this weight in the denominator, does it belong to water or to sulfuric acid?
It belongs to water. This weight of equal volume of water. It belongs to water. Which one are you talking about?
This weight here.
And this one belongs to solid.
Hmm?
The numerator belongs to solid.
Mm-hmm.
And the denominator belongs to
Water. Okay, so now what do you know? Okay. Okay. Explain what you now mean by weight of equal volume of water. Do you have any idea of what it actually means?
It means this sulfuric
Acid.
acid is in liquid form.
Okay.
It's in solid form.
Are you sure it's solid form?
It's in solid form.
Okay. No, let me help you. This weight of sulfuric acid. This sulfuric acid has a weight. Okay? It has a weight. Now, weight of equal volume of water. Weight of sulfuric acid, not weight of water. Weight of water that have, weight of water that have the same volume with what? Sulfuric acid. Is it clear? Weight of water that have the same volume with what? Sulfuric acid. This is sulfuric acid. It has a particular volume, right? That has this weight, right? Now, that particular volume here, you get the same volume of water, and now check the weight of that water. This is the weight of sulfuric acid. It has a specific volume, right? Good. Let's assume that the volume of this sulfuric acid that has this weight is 2 liters, for example. Now you now get the same number of liters of water and check the weight of it. That's what will be here. Now let's look at this question. This question will explain it better. Yeah. But the weight of water will be different. But even though they have the same volume with sulfuric acid, the weight will be different. So if when you divide the two weights and is less than 1, that means water is heavier than that sulfuric acid. But if the divide it is above 1, that means sulfuric acid is heavier than water. From this one now, see the equation. The specific gravity of sulfuric acid is 1.84. What does this signify? That sulfuric acid is heavier than water, because the specific gravity of sulfuric acid is above 1. If it's above 1, that means this weight here, weight of 2 liters of sulfuric acid is higher than weight of 2 liters of water. That's the meaning. If it's above 1.84, That means weight of 2 liter or 5 liter of sulfuric acid is higher than what? Weight of 5 liter of water. So with that, let's solve this question. From this thing now, it's clear that specific gravity is what? Weight of a sulfuric acid over weight of equal volume of water. From this question, what is specific gravity of sulfuric acid?
1.8.
So that means 1.84 is now equal to what? Weight of sulfuric acid, we don't know, because that's what we are asked to find. True of us, over weight of water that has this 5 liter. So if the volume of sulfuric acid is 5 liter, that means the volume of that water is what? That means if the volume of, remember I said that what should be under here is weight of water that has the same volume with sulfuric acid. So if sulfuric acid is 5 liter, that means the volume of water will be what? The same 5 liter now. The same 5 liter, right? Now we'll convert this to weight. Remember I said that in this topic that 1 gram is equal to what? 1 what? Ml of water. True of us. 1 gram is equal to what? 1 ml. But this is in liter, and this is we are told to find it in kilogram. That means 1 kilogram is equal to what? 1 liter. True of us. True of us. That's the meaning. Because if you convert, if you multiply, if you divide 1 gram by 1,000, you get 1 kilogram. If you divide 1 ml by 1,000, you get what? So if you divide 1 gram by 1,000, you get what? 1 kilogram. If you divide 1 ml by 1,000, you get what? 1 liter. True of us. True of us. Sorry. If you multiply 1 gram by 1,000, you get what? 1 kilogram. If you multiply 1 ml by what? 1,000, you get what? 1 what? 1 liter. So that means if 1 gram is equal to 1 ml, that means actually 1 kilogram is also equal to what? 1 liter. So, but the volume of the sulfuric acid, the volume here is 5 liter. Remember, the water and sulfuric acid need to be of the same volume before you can compare the weights. It's not true. So the volume of water here, water is now what? 5 what? Liter. So convert 5 liter to what? Kilogram. You get what? 5 what? Kilogram. So the weight of that water that have the same volume with what? Sulfuric acid is now equal to what? 5 what? Kilogram. Is it clear? So that means the weight of sulfuric acid is now equal to 1.84 times what? 5 kilogram, which is what? Which is what? 9 point what? 9.2 what? Kilogram. So the weight of water, the weight of sulfuric acid, watch out, watch out. Two of them have the same volume, right? Sulfuric acid has 2.9 kilogram what? Weight. 5 what? Liter. Water has what? Sorry, sulfuric acid has what? Yes, 9.2 kilogram, right? Water has what? 5 kilogram and 5 liter. So water and sulfuric acid have the same volume, but the same volume, but weight of sulfuric acid is high, is bigger, because sulfuric acid is heavier than what? Water. So if you don't divide 9.2 kilogram by 5 kilogram, you get 1.84, which is the specific gravity of what? Sulfuric acid. Ask.
You know, they do not give us weight of equal volume of water. They only give us weight of the substance.
They don't give you weight of the substance.
They give us weight of the substance and specific gravity.
They didn't give us weight of the substance. Look at the question. Is weight here you asked to find?
The weight kilogram of 5 liter of sulfuric acid with a specific gravity of 1.84.
They only gave us the volume of sulfuric acid. You now use that volume of sulfuric acid because if you want to compare, you know that this same specific gravity is comparing how that sulfuric acid is heavy to compare with water. True or false? And if you want to know exactly how two substances, if you want to truly compare the weight of two substances, how heavy two substances is, get the same volume of that substance. Like now, for example, now you cannot say, watch now, if you get water, if you want to compare sand and water, for example, now, if you want to know sand and water, which one is heavier, what are you going to do? You get the same volume of water and the same volume of sand. It's not true. And weigh them. True or false? True. So that's where you know exactly the one that is what? Heavier. The same thing happens here now. 5 liters of sulfuric acid, you also get 5 liters of what? Water. But 5 liters of water has weight of what? 5 kg. So you now put it under and use the specific gravity of sulfuric acid to find the weight of what? Sulfuric acid. So weight of equal volume of water is actually what? 5 kilograms. Is it clear?
But is there in some questions, can they give you both of them and tell you to find the specific?
Yes, now, yes, they can. Yes, they can. It can be twisted like that. Sometimes you may even be asked to find the volume set. Okay. If this one is clear, we'll go to the next question. I asked him, by general definition, specific gravity of a substance is equal to what? Weight of that substance over weight of equal volume of a standard. You now go to start talking about what type of standard do they normally use. I say they use 2 standards: hydrogen and what? Water. Hydrogen is used when the substance in question is what? A gas. But water is used when the substance is what? Solid or what? Liquid. All right, let's look at this question. The question says, a modified Rengas irrigation has the following formula: sodium chloride 8.6 gram, potassium chloride 0.3 gram, calcium chloride 0.33 gram, PEG, that is polyethylene glycol 3350, 60 gram, then water for injection 1000 ml. Assuming that 980 ml of water is used in preparing the irrigation, if specific gravity is what? Dash. Now you know that when you see that the irrigation contains this solid, these things and water, right? This thing will dissolve in what? Water. Okay? Now, but these things are in what? Gram. Okay? They are in what? Gram. And for you to know exactly the amount of water used in producing this, you need to convert this to what? Gram. Because you cannot get the exact amount of water when these ones are in gram. So you need to convert the water to what? Gram. Am I communicating? You need to convert the water to what? Gram. Now, if you convert this 1000 ml to gram, you get it, not the water for injection, the exact gram of water for injection used. Now, if you get the exact gram for water for injection used, you now add all these things. You now add what? All these things. They will be in what? Gram. This will give you the weight of the what? Irrigation. Okay? The weight of the what? Irrigation. Remember that specific gravity is weight of a substance, is the weight of equal volume of what? Water. Now, If you now get the weight of the substance, how do you now get the weight of water that has the same volume with this? How do you now get the weight of water that has what? The same volume with this? Now we are told that assuming that now 18 ml of water is used in preparing the irrigation. What the specific gravity is now what? Okay, let's go. Specific gravity is equal to what? Weight of what? Irrigation, right? Over weight of what? Equal what? Volume of what? Water. Now, the weight of the substance is this. Add up this thing. Check if they give you. Add up this thing. This is what? 60 grams, right? Are you sure this is correct? This question is correct. Check well. Confirm this question. I'm just confirm it again. Now, this is the what? The formula. Now, they are saying that assuming that 980 ml of water was used, assuming that 980 ml of water was used in this preparation. Look up. Hello, out together. If you add up this, you know that this water for injection, this is not the volume of water for injection. Hope you know. This is the volume of the entire what? Solution. This is the volume of the entire what? Solution. Okay. Now, and you can't convert this to gram because that pattern is for water alone. Okay. You cannot convert this to what? To gram because that is for water what? Alone. See what you will do. We will use this to know the exact volume of water, exact weight of water in this thing. Okay. Now, we are told that assuming that 980 ml of water was used. We are assuming that 980 ml of water was used. That means 980 ml of water is equal to how many grams? Nine 80 grams now of water. Oh yeah. Huh? Yeah, you're lost. It's not true. See, this question is delicate. Listen carefully, it can be confusing. That's why I'm trying to break it down. I'll be running up and down looking for a way to break it down for you to understand it. Just listen carefully. Listen carefully. If you are told this is the formula, please, whenever you have a solid dissolved in water, it's difficult for you to get the exact volume of water used. You can only get the final what? Volume, okay? But you will not get the exact what? Volume of water what? Used. Now, this thing they gave you here is a clue to determine the amount of water used. 980 ml of water is what? 980 what? Gram of water. See what you will do. Just add these weights of the other ingredients. Add it to 980 gram of water. Okay? You will get the weight of the what? Irrigation. Are we together? Are we together? Are we together? If you add this weight of the other ingredients, you cannot get the weight of water from here. That's why they gave you 980 ml. Assuming 980 ml of water was used. That means you convert this 980 ml of water to what? 980 gram of water. So you cannot confidently put 980 here, water for injection, instead of to add 1 ml. You put just water for injection. It is 980 what? Gram. 980 what? Gram. So if you now want to, everything is now in gram. If you now want to determine the weight of this Ringer's lactate, rain gas irrigation. You add all this and 980 grams. Add it. Add 8.6 plus 0.3 plus 0.33 plus 60 grams plus what? 980 grams. So if you add it now, that means weight of the irrigation is now what? Because the total weight is now what? 0.23 gram. This is the weight of the what? Substance, which is irrigation. Three of us. Remember, we are finding what? This guy. So this weight of substance over weight of equal volume of water. What is the volume of this ringas lactate? Ringas irrigation. Is the volume right? Good. So this ringas lactate has the volume of what? 1,000 ml. So get the same volume of water, right? Of rice, 1,000 ml. Two of us. Then what is the weight of this volume of water? The same volume. Now this water that has this volume will have which weight? The same what? So you will not go by what? 1,000 gram of water. So if you're getting what? 1.0 what? 4 what? 9. So this is still gravity of what? This Rengas what? Irrigation. If you like, you can leave it at 0.1.05. It's okay, not bad. So this is specific gravity of what? This Rengas what? Irrigation. The first thing to do is that always remember that whatever substance is dissolved inside water to form a particular product, to get the volume of water, actual volume of water used is difficult. Unless you start going to displacement value, which is beyond this topic. Now, but the only thing you can do now is to see whether you can convert that water to what? Weight. But we are told that they told you to assume that 90 ml of water was used in this operation. You know, this thing we are added in a particular amount of water, two of us. When it was added, everything now becomes what? The volume of the final irrigation becomes what? 1,000 ml. But they told you to assume that 980 ml of water was actually used. And if you assume now, because all these things are in gram, you convert that water to what? Gram. That's why we converted 980 ml to what? 980 gram. We now use it, add up everything now, and get the weight of the what? Irrigation to the what? 1,049.23 grams. Now, but the volume of this solution of this irrigation is what? 1,000 ml. So this 1,000 ml now turn to get the same volume of water. You have what? 1,000 ml of what? Water, right? Now, what is the weight of that water that has 1,000 ml? It's what? 1,000 grams. That is weight of equal volume of water. You now use it to divide this. And if you divide, you get what? 1.049 or 1.05. It's okay. So that's what specific was gravity of the what? The irrigation. Okay, let's look at the next question. The question says, what is the volume in milliliters of 1 pound? Is that one? Of 1 pound of benzoates having specific gravity of what? 1.83. So they want to compare benzoates of a particular volume with the same volume of what? Water, to know which one is what? Heavier. Okay? Now let's go. Using the formula on the board, if you can see, they are looking for the volume, right? Of what? Benzoic acid. Now, but they have a specific gravity of what? 1.83, and the weight of what? Benzoic acid is what? 1 pound. Please, 1 pound is equal to 454 grams. Put it down. 1 pound is equal to 454 grams. That is 1 pound. Average per pound. It's equal to 454 what? Gram. So if you like, you go back to the formula for specific gravity. Say that specific gravity is equal to weight of a substance over weight of equal volume of water. From this illustration, from this now, what is the weight of the substance of benzoate? Is what? 1 pound, which is what? 454 what? Gram. Now, that means 1.83 is equal to what? 454 what? Gram, right? Over what? X. We don't know. We don't know the weight that should be there. Hope you know. It's also a weight. And that weight is what? Weight of what? Water. Hope you know. That have the same volume with what? Substance. Now, let's go. Now, specific gravity is now this. It's what the what? Weight of what? Benzoate, right? Over what? If you like, you can break this down for easy understanding. Weight of water that has the same volume as benzoate. Is it clear? I think this is a better understanding. Okay? Weight of, so the specific gravity of benzoate is what? Weight of benzoate over weight of water that has the same volume as what? Benzoate. Simple. So we have the specific gravity of benzoate to be what? 1.83 is equal to weight of benzoate here is 1 pound, and I've said that one average per pound is equal to what? 454 what? Gram. So whenever we see pounds, we put what? 454 gram. So 1.83 is now equal to what? 454 gram over weight of water that has the same volume as what? So this weight should be the what? Weight of what? Water, right? Right? So x is now equal to what? 454 gram over what? 1.813. What's the answer? Let's divide 454 by 1.83. 2 what? 0.8. Point what? 248 point what? 1. Okay? 248.1 what? Point 1 what? Gram. Okay? 248.1 what? Gram. This is, listen carefully. This is the weight of water, right? That has the same volume as what? As what? Benzoate. This is the weight of water. But remember what we said. Weight of water. The question said we should find the what? The mole, right? Remember that this weight of water has the same volume as what? Benzoate. So if you're able to find this volume, we have found the what? The volume of what? Benzoate. So let's go. 248.1 gram of water is certain as how many mil? 248 mil of water, right? So if you convert this weight of, yeah, marker. There's no marker here. You can check if these ones are writing. So if you have 248.1 gram, this 248.1 gram is actually the weight of what? The weight of water, right? That had the same volume with what? Benzoate. So if that's the case now, we convert this weight of water to what? Volume. Remember that 1 gram of water is 1 ml of water. So that means 248.1 gram of water is what? 248.1 mil of what? Water. True or false? But this, remember that water and the benzoate have the same volume. True or false? So if that is the case, by extension, the volume of the benzoate is now what? 248 what? 1 mil. Simple. So by extension, the volume of water is now what? Check the other side. Check there first. Check. You also check there. So by extension, the volume of water is now what? 248.1 mil. Is it clear? Just like that. Once you have gotten the volume, the weight of water, you move it to volume. That benzoate and water has the same volume. So the volume of benzoate is what? 248.1 what? Mil. So the answer to that question is what? 248.1 mil. Is it clear?
Sir, this 454 grams, is it gram or mil?
Gram. Which one are you talking about? The last one we got.
1 pound.
No, 1 pound is 454 gram. You know, it's inter-system conversion. We're moving from average to what? Metric system. It's a conversion factor that 1 pound is 454 gram. Any question? So if no question, let's go to the next one when you are done. The last one, okay, you're still copying. Okay, let's look at the next question. The question says, the cost of 1,000 ml of glycerin, what's this? Specific gravity, 1.25, but, so, the cost of 1,000 ml of glycerin of specific gravity 1.25, but at, is it 543? 543 USD per what? Pound is dash.
5.43.
Okay, it's not 543. 5 point what? 43 USD, United States dollars. So let's take it again. The cost of 1,000 ml of glycerin, specific gravity 1.25, but at 5.43 USD per pound is dash. Good. Let's solve this question. They have attached money here now. So let's solve it. Okay, let's see. First of all, let's write down what is specific gravity is. We trace it to glycerin now. Specific gravity is what? Of glycerin, right? Is equal to weight of what? Weight of glycerin over weight. Let's break it down. Over weight of. Let's break it down. Weight of water, okay? Weight of water that has what? That has the same what? Volume as what? Good. I broke it down to a layman's understanding because that weight of equal volume can be confusing, okay? I broke it down so you can understand, we can follow up easily until we get used to it. So now we are told to find what? The cost of 1,000 ml of what? Glycerin, okay? Now, for us to do that, weight of glycerin is what? Do we know the weight of glycerin? What is weight of glycerin there? We don't know. We don't know, right? Good. We'll find the weights and use it to multiply here and get our answer. Just watch out. We are told that the specific gravity of glycerin is what? Is what?
5.
Specific gravity of glycerin is what from the question?
1.25.
So that means 1.25 is equal to weight of glycerin there is what? Is it there? No weight. We'll look for the weight. Okay? We'll look for what? The weight. So we'll look for the weight. We don't know. We call it W. Now, what weight of water has the same volume as what? Glycerin. What are that what? What weight of water has the same volume as glycerin? No.
Okay, 5.43.
No. See. Good. What weight of water has the same volume of glycerin? You can take it first. What is the weight of what is the volume of that glycerin? Is what? 1,000 ml. So that means if the volume of glycerin is 1,000 ml, that means volume of water is also what? It's also what?
1,000 grams.
Let's take it step by step. I say if the volume here it says weight of water that has the same volume as what? Glycerin. You need to find the volume of glycerin first, which is what?
1,000.
So if the volume of glycerin is 1,000 ml, that means the volume of water is what? 1,000. I didn't ask for the weight. I said let's take it step by step. Let me go back to the distribution. I say that specific weight of glycerin is equal to what? Weight of glycerin over weight of water that has the same volume as what? Glycerin. Now, weight of glycerin is what you don't know, you call it W. Now I'm not asking what is the weight of water that has the same volume of glycerin. For us to determine that, we need to even know the volume of that glycerin in question, which is what?
1,000.
Then what is the volume of that of water? If volume of glycerin is 1,000 ml, the same 1,000 ml, right? Good. So if the volume of water is the same 1,000 ml, what is the weight now?
1,000.
Good. 1,000 ml. 1,000 what? That. This is the weight of water that has the same volume with what? 1,000 ml of what? Glycerin. Now with this, now we can find the weight of what? Glycerin. So the weight of glycerin is now equal to what? 1.25 times what? 1,000 what? Gram, which is what? 1,250 what? Gram. This is the weight of the what? Glycerin. The weight of glycerin is what? 1,250. But this is not the question. We are told to calculate the cost of 1,000 ml. If 1 pound of that glycerin costs 5.43 US dollars. So if 1 pound costs 1.53 US dollars, 5.43 US dollars, how many US dollars will 1,250 gram cost? Is it clear? Is it clear? Here it says that from this thing now, 1 pound, 1 LB cost what? 5.43 US what? Dollars. So how much will 1,250 gram cost? That means we need to either convert this gram to pound, right? Or you must convert this to what? Pound. Or you leave it at gram. Move this one to what? Gram. True of us. Any of them will give it the same answer. Any of them will do what? Give the same answer. So let's convert. Converting 1,250 gram to pounds is a long process. You can simply replace this 1 pound with what?
454.
So let's replace it with 454 grams. So that means if 454 grams, by implication, it means that what? 454 grams of what? Cost what? 5.43 US what? Dollar. So how much will 1,250 gram cost? We call it S. So S is now what? 1,250 gram times 5.43 US dollars over what? 454 gram. Gram will cancel gram. So we're left with what? 1,250 times 5.43 US dollars over what? 454. What's the answer? Just multiply 1,250 by 5.45, then divide by 454. What's the answer? 14 point what? So 14.95 US what? Dollars. So actually 1,000 mil will cost what? 14 point what? 95 US dollars. The next question says, calculate the weight of each ingredient and the total weight of the formula for the pediatric what? Chewable gummy gel base for what? Medication. Gelatin for 3.4 gram. Glycerin, specificity 1.155 ml. Then purified water to 21.6 ml. Assuming 15 ml of water was used. Okay, so we calculate all these weight, right? And total weight. Let's go. So we have weight of, we have if okay, if we assume that 50 ml of water was used, okay, let's go. So we calculate the weight of all the what? Ingredient. This question is somehow. They didn't specify how many we are producing. Let me see that question again. Let me see it. Let me see. Calculate the weight of each ingredient and total weight of the formula for a pediatric chewable gummy gel base for medication. Okay, they didn't specify. Okay, so here now, gelatin is what weight?
43.2.
That one is there, right? That one has no issue. 43 point what? For a 4 gram. What of the next one is what? Glycerin. Glycerin is what? Huh? Glycerin 1.25 is equal to weight of it, we don't know, right? Over weight of water that has the same volume as what? Glycerin is 1.155 ml, right? So here should be what? 155 what? Gram. Is it clear? So weight of glycerin is what? 1.25 times what? 155 gram. What's the answer? 193.75 what? Gram. So here is what? 193.75 gram. Here is what? 4 what? 3.4 what? Gram. The next one is what? This whole thing was produced to get to 21.61 ml. Now, assuming 50 ml of water was used. Assuming what? 50 ml of water was used. Assuming what? 50 ml of water was used. Okay, now let's purify water. Purify water, specific gravity of 1. Add it as in to what? 21.6 ml. Now we need to, but we are told assuming 15 ml of water was used. Now, what you do is this. If 15 ml of water was used, listen carefully. If 15 ml of water was used, and the specific gravity of water is what? 1.00. So what weight of water was used? They say that assuming 15 ml of water was used. It's water, not part of the ingredients. Okay. So I say assuming that 15 ml of water was used. So what's the weight of water used?
15 grams.
Food. So 15. This is what for what? For what? Sorry. Gelatin. This is for what? Glycerin. Then water is what? 15 what? Gram. For what? Water. Is it clear? Is it clear? Now, lactose. Now, as what the total weight of the what? Product. Add up all this weight. Add the weight is what? I'm coming. You don't need it, but I'll give you a question now. You need it. I'll give you an additional question now. You need it. Let me know whether you want to see what we're talking about since. So the total weight is now what? 252.15. 2 what? 252.15. For 15 what? Right. This is total weight of the what? Products. Total of what? And the product is what? Gummy gel, right? Sorry. Total the product is what? Pediatric chewable gummy gel base. Now look at it. This is the total weight. Now let me ask a question. If you are asked to determine the specific gravity of this substance, of this product, how are we going to calculate it? You are asked now what is the specific gravity of this product you produce. It's simple. Divided by what?
21.6.
You change to what gram? Oh yeah. The total weight, since we remember, is what? Weight, right? Over what? Weight of the substance. Over weight of the water that has the same volume with substance. So weight of substance is what? 252.15 gram. Now what is the weight of the water that has the same volume with the substance, with the product? You should first of all know the volume of the what? Product, which is what? 21.6 ml. So if the volume of the product is 21.6 ml, that means the water that has the same volume will also be what? 21.6 ml. So and if the volume of water is what? 21.6 ml, that means the weight of water is what? 21.6 ml. So this is what? Gram. So what is the specific gravity of this? Just divide this by this, and you get the answer. Huh? 11.6 what? 74. This is what? You know what does it mean? That it's very far heavier than what? Water. By 11 times heavier than what? Water. As in 11 times 11 times heavier than what? Water. Yes. So this is the gravity of this thing. Does it make sense? I want us to end Kedafia. I want us to finish it. Each year by under one water. That's my target, and we have 80 minutes to go. So get 4 more questions. Let's finish it, okay? We know that we are done with that one. Each year by another question. And that topic, yes. Next one says, The volume in milliliters of 492 grams of nitric acid with specific gravity of 1.4 is, you can say this one now, simple, right? The volume in milliliters of 492 grams of nitric acid with specific gravity of 1.4 is that. Specific gravity is what? Weight over what? Weight of equal volume of water, right? So the substance included in is what? Is what? Nitric acid. So, do we know the weight? We know the weight, which is 492. But we don't know the what? The volume. So let's find the weight of water that has the same volume. Oh, yeah. So what's the weight of water that has the same volume? Check well. Good. Put that the formula now. Solve this question first. Solve this. What are we talking about? At least we solve up to 3 questions. So solve this one. Listen. It's simple. Solve it. Let's see. 3, 5 what?
1.4.
0.4. Is that what you got? 3, 5, 1. Point what? 4 what?
351.4.
4 what?
28.
I mean the unit.
4 grams.
No, you have to how many mil?
Okay, 4 mil.
Let's solve it so we don't waste time. We know that specific gravity is what? Weight of what? Nitric acid, right? Over weight of what? Water that has the same volume as what? Nitric what? Simple. Specific gravity of nitric acid is for 1.4. So that means 1.4. Weight of nitric acid is what? 1.429 grams, right? Over weight of what? Weight of what? Water. Aria. So weight of water is now what? 492 grams over what? 1.4. What's the answer? Huh? 3 what? 0.43 gram, right? The weight of water that has the same volume as what? Nitric acid is what? 3.51 point what? 43 what? Gram. What you can get is just weight alone. We know it's still near, but let's take it step by step. What we calculated now is weight of nitric acid that has the same volume as what? Water. Is it clear? And that weight is what? So I mean weight of water that has the same volume as what? Nitric acid. That weight is what? 351 point what? 43 grams. This is the weight of water. Now, we don't the volume that this weight of water is how many mil now in water? 351 point what? 43 mil of water. Now, remember that the volume of water and the volume of nitric acid are the same thing, right? So that means the volume of nitric acid is now what? The same what? 351.43 mil. That's the answer to this question. 351.43 mil. 351.43 mil. That's the answer to the question. You got it, but I don't know how you got 35.4. Okay, is that what you told me? That's the answer. Is it clear? Then the next question says, let's be fast. The next question says, it says, look, 1971. The volume milliliters of what? Of 1 pound of what? Methyl salicylate with specific gravity of 1.185 is what? Solve it. Let's see. I'll give you 1 minute to solve it. I'll give you 1 minute to solve it. Let's see. 3 what? 3 point what? 1 2 mil. Is that what you got? It's simple now. Since you know that the volume is meter is what? Please go to 1 point what? 185 is equal to what? Weight of methyl salicylate is 1 pound, which is what? 454 what? Gram over what? Weight of water, which we don't know, right? S is now equal to 454 gram divided by what? 1.185. What's the answer? 3 what? 0.12 what? Gram. So you move this to ml in water, then move it to what? Ml in what? In what? Methyl salicylate. True of us. So the answer is what? 383.12 mil. Let's go to the next question. The question says, a drug is required in concentration of 0 milligram per ml. What type of concentration is that one? Is that what you have to say?
Yes.
Let's solve it. A drug is required in concentration of 0 milligram per ml. Okay, let's see. Drug paracetamol for preparing the solution is available with specific gravity of what? 0 point per what? 100 milligram.
The volume of
I don't like this question. Name that.
the volume of diluent to be used to produce 5 ml of solution.
Here with specific volume. A drug is required in concentration 0 milligram per ml. Drug powder stable for preparing the solution is available with specific gravity of what? 0.15 ml per 100 gram. The volume of diluent to be used to produce 5 ml of a solution of the required concentration is dash. Okay, now look up. Specific volume. What is specific volume of a substance? Specific volume of a substance is simply the ratio of, let me explain this better. You know that if you look at this thing now. This thing is a tube, let's say it's a beaker, okay? That contains what? Water. Let's say the water here is at, let's say 20 ml, okay? At this level. You now get a drug or powder, any drug, and put inside this beaker containing this water. If you put it, the level of the liquid there will do what? Increase. True or false? That means that solid will displace specific volume of what? Water. Maybe finally this will not be 22 what? Ml. True or false? Now, that means the volume of water displaced by that thing is what? 2 ml. True or false? True or false? If the volume of water was 20 ml before, and you add a drug, the entire level come up to 22. What it means is that solid, that particular ingredient or drug increase the what? The displace 2 ml of what? Water, right? Let's assume you added 20 milligram of the what? Of the drug. So if 20 milligram of the drug displace 2 ml of water, that means the specific volume of this drug is what? The 2 ml of water displaced over what? 20 milligram of the what? Of the drug. Am I communicating? So this specific volume now is the amount of, is actually the volume of water that is what? Displaced by a specific amount of what? Of a drug, or by 1 gram of a drug, as case may be, depending. But just know that it starts to do with the volume displaced over the what? The amount of the substance added. Is it clear? That's what specific volume is all about. This is employed in drug reconstitution. In fact, there's some drug you will see, like azithromycin. You know, there are some drug in suspension, in powder for suspension. They will tell you to pour water at a particular what? Level before you shake. But if you see azithromycin, especially azithromycin from Zithromax, from Pfizer, they will not tell you to pour water to somewhere. They will just tell you pour specific amount of water inside it, and you get the volume, this concentration you are looking for. How were they able to do that? They carry that. The researcher know the amount of azithromycin that will displace a particular amount of what? Water. That was how they got it. So they use the specific volume of azithromycin to do the calculation. So each of these drugs has their specific what? Volume. Is it clear? Now, with that understanding, let's look at this question again. It says a drug is required in concentration 0.0 milligram per ml. Drug powder suitable for preparing the solution is available with specific volume of what? 0.15 ml per 100 gram. Then the volume of diluent to be used to produce 5 ml of a solution of the required concentration is dash. I don't like this question. Something is wrong with that question. Something is wrong with that question. I've been trying to figure out. This thing means something. I'm not confused with it. How can a drug is required in concentration of 0. No. Okay, let me just solve with 0 milligram and see where it will take us to. Let me just solve with what? 0 milligram and see where it will take us to. Because there's no time. Maybe later, if I confirm that the question is wrong, at least we don't understand how to solve it, okay? So I don't want to start going to I don't want to go and start looking for the original manuscript, because if there's an error in that manuscript, I would have corrected it there. But let me just solve it, even though I know that this doesn't make sense. But let me just use it to solve it, to show you how to solve this calculation, okay? Now, it said that the drug is required in concentration of what?
0 milligram
per ml. Then the drug powder stable for preparing the solution is available. So the specific specific volume of the drug itself is what?
0.15.
So what it means is that 100 milligram of the drug will displace what? 0.15 ml of what? Water. True of us? Good. Now, the volume of diluent to be used to produce 5 ml of a solution of the required concentration. Now, the concentration required is what? 0 milligram per ml. Now, watch out. Watch out. 100 milligram displaces 0.15 what? Ml of what? Of water, or the diluent, as case may be. Now, if you want to produce a dissolution, you want to produce 5 ml of the solution, the entire solution is 5 ml, right? And concentration is what? 0.15 what? Ml. So that means 1 ml contains what? 0 milligram of the drug. Okay now. So 5 ml will still contain what? 0 milligram of the drug. Okay? That's the meaning, right? Because this is X now. X now equal to what? 5 ml times 0 milligram over what? 1. Everything is what? 0. So if 1 ml contains 0 milligram of the drug, that means 5 ml will also contain what? 0 milligram of the what? The drug, right? Good. So 5 ml will contain 0 milligram of the drug. So if that is the case, this now implies that since this is the volume of what your final solution, remember, since 100 milligram of the drug displaces what? 0.5 what? 1.5 what? Ml of what? Water. Now, if you now introduce it now, how many we find the milligram here? That's what we use to know how many volume this milligram will displace. Since there's no milligram now, so 0 milligram will displace how many volume of water? X. Oh yeah, 100 milligram of the drug displaces 0.15 ml of water. So 0 milligram would displace what? Would displace X. So X is still what? Everything is still what? 0 what? Ml. Oh yeah. So the drug will not displace anything because 0 milligram will displace nothing. True of us. Now, if that is the case now, that means there will be no displacement. It's not true. Now, so what volume of the what? Diluent will be used to produce 5 ml of a solution. Had it been that this particular weight will displace a specific volume of let's assume that it displaces 1 ml of water. That means if you want to produce this thing, the volume of the diluent you add is just 4 ml. Because if you add 5 ml, the volume will increase to what? 6 ml. True of us. So if you have to subtract the volume of the entire solution, this volume here that will be displaced by the substance from the volume of the entire what? Solution. So that means the volume of the diluent, had it been we got 1 ml here, that means the volume of the diluent to be added with what? 4 ml. For it to produce 5 ml at the end. But since this here will turn on 0, at this point, I think I'll go and look for my manuscript. This doesn't make sense to me. Just give me like 1 second and few seconds, I'm coming. I just explained this to tell you how to solve it, but I'm not comfortable with that question. Let me look for the original manuscript. Let me know whether there's an error there or not. I said, please correct that thing. It's an error. I've seen it. It's an error. That thing is 20 milligram, not 0 milligram. It's what? 20. Please correct it, please. It's 20 milligram, not 0 milligram. So with that now, we can solve the question. We have already solved it, but I just want to, let me put the correct value. Is 20 milligram. Now let's look up. I've explained what we mean by specific volume, right? Now look, watch out. The question say that the required concentration is what? 1 ml contains what? 20 milligrams. So let's change it now. 1 ml contains what? Are you looking up, Ezekiah? 120 contain what? 1 ml of the entire solution contain 20 milligram of the what? The drug. Now, But we are producing 5 mil. Remember, we want to produce what? 5 mil. That means 5 mil will contain S milligram of the drug, true of us. So X is now equal to what? 5 mil times 20 milligram, right? Which is 100 milligram mil divided by 1 mil is what? 100 what? Milligram. So the amount of the drug in 1 mil is what? In 5 mil is what? 100 milligram. That the entire solution is 5 mil, but the drug inside is what? 100 milligram. But we have to consider the volume that will be displaced by that drug. True of us? True of us? Now, if 100 milligram of this drug itself displaces 0.15 mil of water, if you now want to produce the solution, if you mistakenly add if you don't take, since 100 milligram of the drug will displace 0.15 mil, if you're not careful, the entire solution will be what? 5.15 mil. If you don't put into consideration this displaced volume, you end up producing 5.15 mil of a solution, and it will affect the concentration. It will bring down the what? Concentration. So to avoid that, you subtract this 100 milligram will displace 0.15 mil. You subtract this 0.15 mil from the what? 5 mil. The remaining one is what? 4.85 mil. So what the diluent you will add, if you get 4.85 mil of diluent like water and dissolve the drug, if you get 4.85 mil of water or diluent and dissolve 100 milligram of this drug inside it, the final solution will be what? 5 mil. But if you just get 5 mil of water and add 100 milligram of this drug, the final solution will be what? 5.15 mil. It will be more than the required what? Volume, and it will decrease the what? Concentration, because the volume will increase. True of us? Good. That's the importance of taking what? Displacement value. That's what they calculated in that zero mass. And they not tell you that if you just get water, get 9 ml of water and pour into this powder, you get 15 ml of azithromycin, something like that. This is how they calculated it. Does it make sense? This is how they calculated it. They use the specific volume of azithromycin to do that calculation. So the same way now here, the specific volume of this drug is what was used to do this what? Calculation. So since you know, now let me illustrate it well. If you mistakenly go, let's assume that the volume of water is 5 ml, right? So if 100 milligram of the drug displaces 0.15 ml of water, see what will happen. If you carry it and add here, the final solution will be what? 5.15 ml. But if you say, okay, since I now know that it has specific volume of 100 milligram, 0.15 ml per 100 milligram. That means 100 milligram will displace what? 0.15 ml. If I want to add 100 milligram to this thing, I will not use 5 ml of water. Instead, I will use what? 4.85 ml of water. So that if I add 100 milligram of the drug, it will go up. It will add extra 0.15 ml, and the entire solution will become what? 5 ml. True of us, because 4.85 plus 0.15 is what? 5 ml. Does it make sense? Yeah? Good. Okay, so that's what specific volume is all about. Okay? Now, let's look at the last question before we okay, sorry. I read it. Please write it down if you're writing. Let's solve this last one. Then we have tried. Yes. Let's look at this question. The question says, calculate the quantities required to prepare sufficient suppository. Let me be calling from here. Calculate the quantities required to prepare sufficient suppository mixture. Yeah, mixture, not mixed. Mixture for 12 1 gram suppositories, each containing 50 milligram of what? Menthol. Displacement value is what? 0.7 in theobromine what? Oil. What will each suppository weigh? Assume that the method of preparation means that the pharmacy technician will need to make an excess of the mixture, and so it will be necessary to calculate the quantities for the suppository preparation of what? 15 what? Suppositories. We are preparing what? How many suppository? 12. Average, you do what? Prepare for what? 15. From there, you take the one you need, okay? Now, you know that in this preparation now, let's assume now, if you get the mold, let's assume that the mold the mold you want to use in preparation contain only the base alone, okay? Contain only the base. You know that tuboma oil is a base. It's a suppository base. Now the base the mold you want to use contain only the suppository what? Base. Now, if you put the drug active ingredient in that suppository, it will displace some amount of the what? Base now. Aria, it will displace some amount of what? Base. So that is what you mean by what is now the value of that displacement value. What does it mean? You need to, the same way you must check specific volume for liquid, for preparation, you must check what? Displacement what? Value. Each drug has its own displacement value in a particular what? Base. Now, if the displacement value of this is what? 0.7. So what does it mean? What does it mean? What does it mean? The question says that you are preparing what? 12 suppository, but you prepare for 15 in case, and each suppository is 1 gram. Is 1 gram, right? Right? So you multiply by what? 15 suppository, right? Which is what? 15 what? Gram. Am I communicating? Which is what? 15 what? Gram. Now, let's assume that everything in this suppository is only base alone. Only what? Base. You have not added active what? Ingredient. Since if 1 gram is 0.7 gram. Okay? We are told, okay, let's check the active ingredient here first. What is the amount of active ingredient in one suppository? 50 milligram, right? This is only the what? Base. Now, amount of active ingredient in one suppository is what? 50 milligram, right? How many will be in 15 suppository? How many will be in 15 suppository? 750 milligram will be in what? 15 what? 15 what? 15 what? Suppository. Am I communicating? Now, but this is only the mode when it contains only the what? Base. It weighs this, right? But the 50 milligram that will be in 15 suppository is what? 750 what? milligram. Now, let's go back to the displacement value. If 1 gram displaces 0.7 gram. Now, what will 750 milligram what displace? Is it clear? So we have S is now equal to what? 750 milligram times what? 0.7 gram over what? 1 gram. Gram cancel gram. 0.7 times 750 is what? 0.7 times 750 is what? 5 what? 525 what? No, milligram. Milligram, right? Right? Then convert it to gram is what? $5.25. Sorry. There's something I want you to check now, please. Do something like this. Let this 0.7 come here. I want to confirm something. 1 gram. Okay. Let's see. So we are multiplying this by 1, right? So divide 750 by 0.7. $750 by what? Divided by what? 0.7 is what? Divided by this is milligram, right? Divided by 1000 is in gram. Is 1.0, then minus 15 gram. So with this now, see what I want to cross check an error here. There's an error here. That's what I checked. It should be the other way around. That's 0.7 gram is what? 1 gram of what? So what it means is that if you say that a substance has a displacement value of what? 0.7. Put this in down. If you say that a drug has a displacement value of what? 0.7. What it means is that 0.7 gram of the drug will displace what? 1 gram of the what? Theobromine what? Oil. That's the meaning. Okay? If you say that a drug has displacement value of what? 0.7. What it means is that 0.7 gram of the drug will displace what? 1 gram of what? Theobromine what? Oil. Does it make sense? Now, if that's the case now, that's what this means. So the mode that has filling the mode alone. Are you listening? You have 1 gram times 15, right? Which is what? 15 what? Gram. This is only the what? Base. But the drug itself is 50 milligram times the same 50 suppository, right? It's 750. So, but you need to add this 750 milligram of this drug into this base. And if you add it, it will remove some of the base. True of us? True of us? So if you're not careful, if you don't do it, if you remove some of the base, that means you are supposed to know the amount you should remove. So before using the base, is that exact amount of base remaining that you add. But if you add 15 gram, If you add this with 15 gram directly, it will be too much. Just as the same way that solid will displace water. This drug added in suppository will do what? Displace the what? Base. And what's the excess base here? Which is not good. So the best thing is this: if you know how many this 750 can displace, you better remove it from the base before you start adding the what? The drug itself. So that everything will give you the normal weight you are looking for. True or false? Now, with that, now we can now solve this question. We have known that 15 gram of the suppository is only the base alone. We have known that the drug is 750 milligram in 15 suppositories. So using this displacement value, we say that 0.7 gram of the drug will displace what? 1 gram of what? Theobroma oil. Therefore, 750 milligram will displace what? X. Is not true? So X is now what? 750 milligram times what? 1 gram divided by what? 0. What? 7 what? Gram. 750 milligram times what? Times 1 gram divided by what? 0.7 gram. Gram will cancel what? Gram. 0.7 divided 750. You get what? That you gave me is what? 1 what? 1,000 what? 07 what? 14. 1071 point what? 42 milligram, right? Move this to gram. That means you divide by 1,000, right? So if we move it to gram, it becomes what? 1 point what? 071 what? 4. Let's leave it at this level. 1.07. Do you know the meaning of this? That immediately you add this 750 milligram of drug inside this thing, it will offshoot 1 what? It will displace 1.071 what? Gram of the what? Base. So if you want to produce this thing now, the actual amount of base you should use is subtract this from this. Is it clear? So subtract 1.0714 from 15 gram. What will be the answer? What's the answer? Minus this thing we got here now, 1.07. Do you understand what I'm saying? Since minus the one that it will display. Remember I said that if you just carry this in and put here now, 1.7 will come up. It's not 1.07 will come up, and it will be the weight will be too much. So to avoid the weight being too much, remove that amount that should come up from here, so that you know the remaining amount of what? Suppose it's a base you add. So if you subtract, do 15 gram minus 1.0714 gram.
13 minus 13.92.
The answer is what? 13 point what? 9 what? 2 what?
93.
Okay. 13.93 gram of theobroma oil is what you need. Remember the question says what? The question says the quantities of this base you need, okay? So the question, the base you need is what? 13 point what? 93 what? Gram of theobroma what? Oil. Is it clear? Then it also wants us to know calculate the weight of the what? Each suppository. So remember that the entire suppository you produce will now be what? With what? The weight of the entire suppository. No, that 13.4 is the weight of the what? To oil you add. It's not you use. That's weight of the base you will use. Do you understand this thing? Are you sure? You are doing as if you don't understand what I'm saying. As in, we have this question has two parts. We should calculate the quantity of what suppository base you need. At the same time, we should calculate the weight of each suppository. Now, before you can do that, you need to calculate. You need to check the weight of the entire base you produced. What will be the weight? Simply add this starting point. Add this starting point. What is the weight of suppository?
13.93.
Is the weight of the suppository base you are adding? You are making, right? You are adding, right? Then add suppository weight of the suppository base to the weight of the active ingredient. That will be the weight of the what? Suppository. Convert it to gram so that it will rhyme. Same 15. If you convert same 15 milligram to gram, what will it give you? Good. So the weight of the active ingredient you added for 15 suppository is what? 0.75. Then add it to the weight of the base, which is 13.93. So just add 0.75 plus 0.75 plus what? 13.93. What's the answer? 14.68 is the weight of the entire weight for the 15 suppository. Is it clear? Because this is for what? 15 suppository. So the entire weight for the 15 suppository is what? Because you actually calculated for what? 15 what? Suppository what? Base. True of us. Now, so the weight of the entire thing you mix is what? 14.68. But what will now be the weight for one suppository? What will we now do? Subtract it. If 14.68 is for 15 suppository, so what will be the weight for one suppository? 15. It will give you what? Simply divide by 15 now. What 15 is 14.68 gram. So one suppository should what weight? I check now. I'm not comfortable with you. You people are doing as if you don't understand this thing. No, seriously, are you just waiting for the answer? I don't know. If you don't, please, you need to understand this thing. Seriously. If you are mixed up somewhere, let me know. You are not cooperating. To find what? Yeah. How do you now? Should we wait? Should we you be doing compounding here in the lab? So how do you know the total weight of for a solid preparation? How do you know the total weight? It's not the total weight of all the ingredients you used plus the base. What is the weight of the base here for the 15 suppository? What is the weight of the base we use here? 9 what? So what is the weight of the active ingredient for the 15 suppository? Which is what in gram? So what is the weight of this? What is the total weight for 15 suppository now? So what is the issue now that you don't understand then? That's the weight for the 15 suppository, right? I'm not asking now what is the weight for one suppository. No.
14.68 divided by 50.
Hey now. Yeah. Now what do you know? How? 14.68 for 15 suppositories.
So you divide it
15 weigh 14.68. So one will now weigh what?
0.997 or 0.98.
It's actually about 13 points. The final answer, that is the weight of the.
Do you even know how we arrive at that final answer? Are you sure? Okay. It's what?
The answer of the base is 13 point something.
For base. Base for 15 suppository.
Yeah. Then
13.93.
Then even I just get out how many. Okay, one for the one distance suppository. Because if I calculate it is for 15 suppositories, then for one suppository, is the answer divided by 15.
Yes. But overall, it's not the base you're dividing into. You just mentioned the base. You haven't mentioned the total weight because the base, if base weight of what you produce for solid preparation is weight of all the ingredients. Now you only mention base. You really add that of active ingredients, which is what 0.1. So it adds the obligation 14.68 grams. But that is for 15 suppository. So what will now be the weight for one? You go by 15. Oh yeah. And that means the weight of the one suppository is what? 0.98 gram. Why the amount of base you need to add is what? 13.93 gram. That's the end of the questions on this specific reality. All right, I don't know if there's any question. I think we'll stop here. Tomorrow we'll continue from which one again? Tomorrow we'll continue from what do you call it again? C75. Have you sent that now? Ask you to send. Send it here now. Send it, please. I need it this 6 nights. There. I promise you that I'll send these things, but I've not done that because I lost that and I don't have to start sitting down and start comparing again. Please send it now, please. All right, thank you very much for your attention. See you tomorrow. God bless you.